Okay, yeah, hi, good evening, everyone. Welcome to the revision session for Quiz-1 and Qualifier exam. So, I hope you have already done all the 4 week content and you have revised the content. So, basically, if you have done all the practice assignments, practice theory assignment, graded theory assignment, and now we have also released the mock paper, so that is also a very good idea, so you can take idea how what are the type of the question actually generally asked in the final exam. Okay, so I cannot teach complete all complete topic of week 1 to week 4 in one session. Okay, so I'll just discuss some important topic today, so which are actually more important, or we can say that you should need more focus on that topics, okay, to revise the concept. Other things, we will strongly suggest it to you. Just see the explanation of the solution of question, graded assignment questions and practice assignment also. We have also released the detailed solution of the practice assignment question theory, and so please look that. And we have also released the some summary notes, PDF notes, for first 4 weeks, so just also visit that document. Okay, and these documents are available in supplementary content. Okay, so before starting, if anyone have any query, you can raise your hand and you can ask. Okay, so I'll take your query according to your raise hand order. Okay, any query before starting the session? Yeah, है मनाथ रवि.
Sir, whether exams will be conducted in centers or in online, sir?
No, this qualifier exam will be conducted on center. Qualifier
Okay,
and
sir.
quiz, all these exam will be conducted on a center. Only the programming exam will be conducted through online mode.
Okay, sir.
Okay, so
When
that
will be the
exam,
exam,
yeah,
sir?
that exam will be held after the qualifier. So quiz, so after week 7.
Okay, sir.
So this is only for the student those who have qualified the course and that qualified the qualifier exam, and those who have entered into the program and enrolled this course.
Okay, sir.
Okay, for this term. So
Sir,
that
whether hall tickets have been sent, sir?
so you can check your dashboard. That dashboard, I think.
Sir, I have some problems in dashboard, sir. I have mailed it to one support team.
So other can anyone confirm this that hall ticket is available or not till now?
Yes, sir, it is released.
Okay, release now. Yeah.
Okay, sir.
So
Thank you, sir.
you not receive that your dashboard is not opening. Why?
Yes, sir.
What is the issue?
Sir, it is showing to um, pay for an September month exam, sir.
Okay, September month exam. Okay,
Yes, sir.
so I think there is some criteria set for like this exam. I think your first 2 week score is not good, I think. Am I
Okay,
right?
sir.
So
No, sir, I have
maybe,
done well.
yeah. So that is, I think, some criteria. If you have qualified for the the qualifier exam in first 2 weeks due to good score in first 2 weeks, so maybe you are eligible for the exam of this month. Otherwise,
Okay,
maybe
sir.
like this, there are some criteria. Please check on the website.
Okay, sir.
Okay.
Thank you, sir.
Yeah. Okay. Any other specific query? Yeah, there is one another reminder. I am just telling you. So those who are planning to enroll the C course after qualifying the qualifier exam, and those who have already enrolled in this course as a term student, so we are starting the timed lab assignment, timed programming lab assignment from tomorrow. So the first timed programming assignment will be released tomorrow, and this will be released 4 day basically. So Saturday, Sunday, Monday, Tuesday, and in night 8 to 10 p.m. So you can attend this assignment in any slot. and you just complete it. Okay, so this contains to 15% weightage in the score, as well as the OPP2 actually depends on this performance. So do not
Sir,
skip this. Yeah.
will it will be same for all the days or will it will be different for
Yeah,
all the days?
same,
Because
same. So in every timed lab assignments, you will get four programming problems, and that four programming problems will remain same in all days of the week. So suppose if we are releasing this week 4 days, so these problem will remain same. Okay, so that means you can complete this problem in this manner. So you can complete like two problem today, tomorrow, and two problems in the next day. So you can also do in this manner. Okay, and these first timed assignment problems will be based on the week 4 concept, that like this loop and conditional statements. Okay, and so other things is also required from week 3, that operator and variable like this. So not week 5 content. Okay. Yeah, yes, Kumar.
Yes, sir. I have doubt in continue and break statement that we use in the like in the programming.
Okay, okay, yeah, that we will discuss today in the revision. Okay, sure. Okay, so what about those who didn't qualify for 7 July? Okay, Smita. So, yeah, you can prepare yourself after completing these contents. So, you will be eligible for the maybe next month exam. At that time, you can give the exam. So, just confirm this with any support member or ops team. I'm not have clear idea this also. Okay, but I think there is some criteria like this. You can check the website or like instruction encoding. Okay. Yeah, so this instruction encoding is not too much important, because this is just to discuss some basic idea how that CPU works actually in at the machine level language. So do not just try to go into deep this. What is the instruction meaning? If we are asking any question related to this instruction coding in exam, so we give the explanation for each instruction. Okay, as a comment. So do not try to remember all these instructions, that add, sub, that load, and that store. This is actually not the purpose of this course. So totally for the specific this instruction or assembly language things, we have another course separately, that computer architecture. So that contain the detailed information. So do not try to go in deep for this topic. Okay. So let me share my screen, and let's discuss some important point. Okay, week wise. So in between, please ask clear your doubt if you have any doubt in the topic. So actually, I hope my screen is visible to all.
yes, sir.
Okay, thanks. So basically, in the first 4 week, these are the topics where you need to give more focus for the exam. So first thing, basic of the computer. So basic of the computer means you should know the architecture. What is the architecture of computer? What is the CPU? What is the memory? And what are the internal part of that CPU? So you should know what are the working for each component of the CPU, and memory, and type of that components. So that we will discuss. Okay, today. So, and another is memory model based computation. Okay, so this question we have already discussed in week 1 and week 2. So some that registers, and these questions are actually very related to the programming, any program in any C program. Okay, if you have already done week 3 and week 4, and now if you try that question, that memory based question, so which we have already seen in week 1 and week 2, you will find that question are not too difficult. Okay, just follow the instruction and do the computation in the same order. Then you will get some output, that return the output accordingly. So that based question are also important for the that quiz exam. Another is third point is data representation. So data representation is from week 2. So where we are discussing some data like this binary number and that hexadecimal decimal number, octal number, and this decimal number. So these three four type number we are just learning in this course. Just we are looking for these data representation, and after that conversion of each other. Okay, so like suppose if you want to convert that decimal to binary, binary to decimal, any binary to hexadecimal, so these conversions should okay, so for the exam, so some any type of conversion may be asked. Okay, so this conversion is important, and you should have good understanding of data representation like this binary, hexadecimal, octal, and decimal. Okay, and apart these 2 points are basically from week 3 and week 4. So week 3 you should know about the data types. Okay, and why we use these data types, and what are the data types in C, variable and rule of variable naming, and operators and operator associativity and precedence. So these are the topics from week 3. After that, from week 4 you should have good understanding of the loop syntax and conditional statement in C. Okay, so we have already seen loop, for loop, while loop. You should know the proper working of the for loop and while loop. If any code is given, so for week 4 basically the code based question asked. Okay, so some code snippet will be given, and uh, you should apply the dry run. Okay, so because you don't have any compiler in the exam, but you should know how the compiler actually will execute the code. Okay, so you should have good understanding of the loop, which you are learning in week 4, and conditional statement also. So we have already seen this if else and that switch statement in week 4. So with the help of these loops and conditional statement, if any program is given, so how you can that run that program, that by the paper and pen on the, okay, not on compiler. So that means you have to think like a compiler, and then you will execute the programming steps manually. Okay, then you have to return the output of the code. So like this. So you should have that good understanding for the for loop conditional statements from week 4. So, and for week 4 you should have good understanding for week 3 also, because that also contains some uh, basics of the C, like this operator and associativity, variables, data types. Okay, so these 2 weeks, last week 3 and week 4 is basically to just programming based question. Okay, and some in that properties based questions, so like data type, that variable name, a valid variable name, like this. Okay, but previous all the first 2 weeks are basically theoretical, and some computation based question you can expect that in the exam. So that we have already seen in week 1 and week 2, and so that we will discuss today. Okay, so now first things, we will start from basic of computers. So I'm opening the same notes which I have already uploaded in the supplementary content. So I'm just quickly revising the top that things. So basically, what is a computer? Computer is just an electronics device that performs some computation, that process the input data and perform computation and return some output in to the output device. Okay, so we have some input device, output device, and in between we have some control, that processing unit. So that is called as a central processing unit that perform this arithmetical. We also say that this is a control unit and arithmetic logical unit. So that performs this arithmetic operation and logical operation. That is basically called as a CPU. Okay, central processing unit. So, and apart from that, our computer also contain this memory. Okay, so this memory also play a important role for this computation. So we need to store the data during the computation. So that memory is required. So this is memory RAM. We have the one type of memory that is actually store the data which are actually currently that processing. We can see that if any program is executing by the CPU, so related data actually comes under the RAM memory, random access memory. That is this is the memory of type volatile memory. Okay, so volatile memory. So volatile means when we will turn off the power, that the data which is inside the RAM actually will be removed. Okay, so because of this is called as a volatile memory, but it is temporary stored used the storage used for actively running program and data. Okay, suppose we are running in general example, suppose if we are running some video in our computer. Okay, so video, some application is running which are actually running some video, so that application is a collection of some instructions. Okay, so that is also collection of some programs, so that programs are running internally in by the CPU, and the data which we are actually giving as for running, that is actually a video. So that data and program which are currently running by the CPU, so related data comes under the that comes to the RAM memory. So this data is actually stored in the hard disk, so that is actually a permanent memory. So we have lots of data in our computer, so the lots of data is stored actually in our hard disk, so that is actually permanent memory, and that is actually non-volatile memory. When we turn off the power, our data will remain exist. So the relative data which are actually running in the at the current times, so that data actually transfer from this hard disk to RAM memory, and CPU interact with communicate with this RAM to fetch the instruction, fetch the data, to execute all the things. Okay, so data can be read from and written to RAM quickly. This is by the processor. So this is a volatile memory, so that means data is lost when the computer is powered off. So these are some important point about the RAM memory. Okay, and storage device. So that storage device means RAM store the data temporary, but we need to store data permanently. So we need some non-volatile memory to store the data. So now this SSD is more popular. So previously this another hard disk and another tape drive, there are many type of memory which generally used for the permanent storage, so that is called as a external memory, we can see that. And so this is another category of permanent memory. Input device and output device. So you know that we are giving some input to the computer from any device, or maybe keyboard, mouse, and these things, touch screen. So all these things are called as input device, and we are getting some output on some device, so that is called as the output device. So these are some very basics of the computer. So motherboard is a board where all the things actually are situated. This CPU, RAM, all the things are actually exist, and all actually connected through some communication channel. Okay, so that is a board called as a motherboard. And software, yeah, software is required for our computer, so that actually performs operations and tasks. So this is also a collection of programs or collection of instruction, we can see that computer actually perform tasks.
Sir, can you give the example of the working difference of CU and ALU?
CU and ALU. Okay, okay. So I'm coming on this on that. Okay, so that architecture I'll come. Okay. So how computer work, that input stage, processing stage, memory storage, control units, all these are actually the steps actually where the computer works. So input stage, the computer takes the data, processing the data, then store the data. So this data is actually stored in some place like this RAM, ROM, and secondary storage. So ROM is also a one type of memory that contain the store data permanent. So permanent storage containing essential system instructions. So like operating system, when we turn on our system, so how that window is actually loaded, that okay, so that there is one program that is stored inside the ROM, and that program actually runs initially when we turn on the computer, and after that operating system loaded, then after that operating system handle all the things. So that one type of memory, ROM, read only memory, and we cannot update this easily, so that is called as a read only. Okay, so control unit we have. So I'll discuss this control unit with help of the architecture. So arithmetic, yeah, this is the main part. This is we called as a CPU, and after that output stage, all these things are some communication things. Okay, so let me just move to the next part. Yeah, CPU main. This is the main. central processing unit CPU, and this is the architecture which you know that professor have used in this lecture. So yeah, communication happen from here. So this is the input part. Some data is giving as a input to the computer, and after that, this is the part is called as a CPU. Okay, and CPU is a combination of this combinational logical. This is called as a ALU. Okay, so ALU, arithmetical logical unit. Okay, so this is a circuit like we can see that, and this perform the main computation, arithmetic computation, logical computation like this. Okay, so the and the CPU also contains some registers. So this register is also a memory, small memory, which is located with us. That ALU, and that store the data, which is actually using during the computation by the that ALU. Okay, so suppose if ALU is performing some computation, and for for computation it needs data in some memory. Okay, so suppose if it is performing like a plus to that a plus b value. Okay, so that ALU will fetch the data for a and for b, and for temporary this data will be stored in some place. Okay, so that data will be stored inside the registers, and after that, what is the sum of these two values, that will also be stored inside the registers. Okay, so this is the closest memory for that CPU, that ALU, that actually used for the computation. Okay, so this is called as a registers, and this complete part is called as a CPU. And apart from that, we have main memory. Okay, so this is the next level memory, and in between there is one more memory, cache memory, that is also comes. So sometimes that comes under the CPU, so and sometimes it comes outside of the CPU. Okay, but this is just that cache memory also play an important role if any data is frequently coming for the computation to CPU. Okay, suppose if this CPU is performing some task or some running some application, but some any task is repeatedly coming on the CPU. So that means any data or any instruction set are repeatedly coming on to the CPU from main memory. So that cache memory actually holds that data for some time, and that data actually direct fetch from the cache memory if it is required again and again, not from the main memory. Okay, so most of the data fetch from the main memory actually. Okay, so that main memory contain the data related to the program and that instruction and data, and that CPU communicate to the main memory. But if any data is frequently coming, that data is stored inside the cache memory for some time, so it saves actually time for fetching that communication. Okay, so that CPU direct check in the cache memory if it is available, so that data is actually fetched from the cache, not from the main memory. So it actually increase the computation time. So that is one type of memory, and this control unit basically handle all the things. So that communication, how this communication is happening between this processor, that CPU to main memory. So instruction are fetching from main memory, and it is loading to the registers, and that data which is stored in the register, that is storing into the main memory. And so that data movement, communication, all is actually controlled by this control unit.
So,
So
sir, a control unit is like a kernel just for CPU.
kernel, or you can say according to the name, control. So this actually control the things, actually control the instructions. So how
Yeah,
this,
like in
yeah,
OS.
communication, or we can say that communication. So that which data will be transferred where, so that actually handled by this control unit. Okay, so main memory, suppose if some data is required from main memory to CPU, so that actually control unit will send some command that to main memory, so that data will be fetched from the main memory, and it will move to the that registers like this. Okay, so all these instruction passed by the control unit. So actually control unit is controlling all the communications like this. Okay, and after that there are two more, one that IR and PC. So these are also two important registers basically. Okay, so this instruction registers, and one is program counter. So this program counter is basically a registers that store the instruction which will execute next. Okay, so this is also a type of registers. And instruction register is also a register, or we can say that memory that store the current instruction which are executing by the ALU. Okay, so these are two important registers you should know. So what is the purpose for this instruction registers and program counter in our CPU? So you can see control unit manage and coordinate the operation of the CPU. Okay, control the flow of data and instruction within the CPU and between the other hardware components. So this actually manage the things between that coordinate, that it provide the coordinate between the CPU and hardware and memory. So apart from that, ALU basically the purpose is only to perform this logical operation, arithmetic operation. Okay, so the addition, subtraction, multiplication, division, logical operation, and or not, and some decision making control statements, uh, like this type of operation performed by this ALU. Okay, so this is the main part. And registers are basically are a small memory and store the data which are that is actually stored for temporarily during the computation. Store data and instruction temporarily during the processing include the program counter. So yeah, you can see program counter, that is for to store the instruction that will execute next, okay, after the current instruction. This is store the current instruction. And general purpose register, so that is basically to store the another required data which is actually required for the computation. Okay, so function, yeah, instruction execution, data processing, all these things are related to the more computer memory this not too much important. Okay, for going in deep. So data processing, control of verifiers, yeah, these are some function of the computer. Okay, and apart from that, another important thing is memory hierarchy. Okay, so we have this so this memory hierarchy is given from the CPU side. Okay, so this, suppose this is a CPU, and what is the closest memory from the CPU? So CPU, the closest memory is this registers. So because of that, this accessing time and capacity, it is given like this. So access time from CPU, so which one is the closure, and the communication will happen fast. Okay, so CPU register are the closest memory for the CPU, so that communication happens fast, so access time is less. So that means access time is increasing in this manner. Okay, so CPU is the fastest, then cache memory comes, then main memory come. Okay, after that all these things comes under the permanent storage. So magnetic disk, optical disk, and magnetic tapes.
Sir,
So
magnetic disk is HDD, right?
yeah, that is SGT.
And optical disk is the CD or DVD writer.
That optical, yeah, another this floppy, there is one, I'm not sure, but yeah, this is the actually old diagram. Now SSD is also come. Okay, so that memory is different types memory. So optical disk is different. Yeah, this CD type, yeah, you are correct. Okay, so but all these category comes under the permanent storage, and it is actually replaced after time to time. So in at many year ago, actually we used that magnetic tapes. After that, it is replaced by optical disk, then magnetic disk, now SSD, this type of category. So also capacity wise, the CPU that registers have less capacity. After that, cache memory have some more capacity, and then main memory have more capacity. Like we, you know that we, when we purchase the computer, so main memory is normally 8 GB, 16 GB, but this permanent storage is actually at the hardest largest capacity, so like 100 GB or 200 or 1 TB, like this. Okay, and also the cost wise also, so the cost actually increase in this way, that okay, so that size wise, if we calculate the cost, so we found that this is the that less price, and this is the highest price. So this is the size that you should know this order. So which one is the fastest memory, which one is the slowest memory, so that order you can remember for the exam. CPU register, so and cache memory, then main memory, then any external device. So I'm not discussing the working and features, all these things. After that, what is programming? So programming, you know that when we write the set of instruction or sequence of instruction for the computer, so computer perform the task according to the given instructions. So that task actually be performed by the that programming. So that programming is just a sequence of instructions. You can see that that is called as a program, and we use some language for that. So that language is actually more that closer to the human. We can say that. Otherwise, that computer only works on the machine code, and that machine code is actually a simple binary things. Okay, so 0101. So that is actually not easily understandable to human. So that programming language is actually designed for that. So uh, human writes the code in programming language, and after that, that programming language compiled by the compiler, and that is converted into the lower level languages for the machine. So some important key point is programming language. You know that C, Python, Java, we have this programming language that provides syntax and semantics. So syntax means that what that keyword we are using, what operator symbol we are using, like this. So that is called syntax. Otherwise, semantic, that means rules. Okay, so we have many programming languages. After that, what is algorithm? So algorithm is just a step-by-step set of instruction used to solve a specific problem. Okay, so that is called as the algorithm. Data structure. So we actually used some data structure to store the data when we are writing any program. So that data structure provided by the language also, and we can also create some user-defined data structure. We can also create, so that are actually a organized way to store the memory in our that memory. Okay, so how we can store the data efficiently in that way. So at any time if we require some data, so we can fetch the data efficiently or fastly, and we can also perform some operation efficiently. Okay, so that some data structure is provided to us, like array. Suppose you have like example, this array is provided by the language. Okay, so C provide this array. So where data is stored continuously. Suppose if we want to store many data, so like we want to store the marks of 100 students. Okay, so we can create a data structure array for 100 student. Okay, now the all 100 student marks will be stored in the continuous memory locations. Okay, suppose first memory location is like 100, so after, and all data type is integer, so integer takes 4 byte. So you can just assume that after 4 byte addition of 4 bytes, so 100 104 next data will actually you can find out in memory. Okay, after 108 you will get the next data. So all data is stored consecutively memory location, consecutive memory locations in the memory in when you are using array. So you can use this data structure, and you can easily fetch the data with the help of indexing. So that data structure also provides some way to fetch the data and some operation also. So you can easily perform the task with this data structure. Okay, so software development cycle. So this is another things. After writing the program, how we can develop the software. So software is just a collection of programs. So we plan something, and after that we write the code, we test the code, that we maintain the code. Like this, there are many steps are there at the software development cycle. So we are not discussing this. Okay. So yeah, these are some basic property of the programming. You can just look this document, and these are some properties of C. Okay, so these are some basic things. So here basic things is about this computer, that memory, that CPU architecture. So that purpose of each component, like ALU, that IR, PC, control unit, registers. You can just revise these. Okay, I'm moving to the second beak 2. Yeah, so second beak, this number, this data representation is very important. Okay, so data representation and conversion, these are actually very important generally. And yeah, also I've that from beak 1, that memory based question. So that I'm just discussing one question. Yeah, so let me discuss this one question, and we'll check. So for this type of question, I hope you have already done many questions, so you understand that how this is actually working. So you can expect some question from the like this type, okay, in the exam. So here, what happens? Some set of instructions are given, and you need to just perform. And perform means just execute these steps. Okay, so you should know how what this step is actually doing. So just perform all the instruction working step by. So you can start from one, then two, then three, like this. And in between, if any control statements are there, so accordingly just jump. Okay. So suppose if this condition is given, if this condition is true, then go to step four. So directly jump to go to step four, and then perform same thing from top to down manner. So these instruction execute in the top to down manner. So perform execution from top to down. At any moment, if any control statements are there, accordingly jump back and then start again from top to down. Okay, do not skip anything. So like do not perform like this. So directly jump from 4 and then coming back to 7 and 8. Okay, so that execution sequence will always remain top to down. This will be controlled by some control statement. So here, to solve this type of problems, us just note down the that storage area. Okay, so these are actually just trace the storage location, so where we are storing the data, and how these locations are actually updating the data, how data is updating in that location. So just note down all these things after every instruction. So you can note down like R0. So R0 is just a memory. Okay, so R0 and R1. R1 we are using here, and R2 we are also using. Okay, you can note down all this. So okay, so all these are the memory which we are using for the computation. Apart from that, we are reading the data from memory location. So these are the registers, and we are reading the data from memory. So memory M0 contains 0. So that data is actually coming to this first register. So we can write like this. So 0 will come here, and M1 data is given 1, and that data is coming to R1. So that data we are loading to R1. So that is coming here. Okay. So this is the initialized things. So what value we are initializing first time. After that, so now this first two steps are we have performed, and that is actually loading the data from memory. After that, this is a assignment operator. Okay, so assignment operator means the right side value. Okay, so always consider this right side as a value, and this is left side as a location. So that value is actually stored at this location on the left side. Okay, if like sometimes this is given a equal to b. Okay, so what is the meaning of this? So that means the value the value of b actually now stored to location A. Okay, always read like this. So yeah, please ask the open your mic if anyone have any doubt. Anyone have raised the hand? Yes, Subhasri. Hello. Okay. Okay, so this statement like R2 equal to 2, so that means we are storing the this right side value to R2 location. So that means R2 is now not initialized till now. So this is the first step to initialize this. So this 2 value will be initialized here. Okay, so now this is the point. What is our question here? If k equal to 6, what will be the value for M2? Okay, at the end of execution. So that k equal to 6 we are giving. So you can just replace this by 6. Okay, k. So now just perform the same thing. So now step number 4. Step 4 is R1 equal to R0 plus R1. So that means this side, this is a expression. When we are computing something, so that is expression. After computing this expression, that result will be stored into this R1 location. So right side value is just read as a data and perform the computation and stored at this location R1. So R0, what is the R0 current value? So always read the current value and update. So R0 is now 0. Okay, so I'm writing like this. So R0 is 0 plus, and R1 is currently 1. So 1. Okay, and now this sum is now you will get 1, and 1 is storing to R1. Okay, so now you can see previous value is still same. R1 equal to R0 plus R1, so you will get 1. So that means you are updating this, but same value 1. So now there is no change. After that, R0 equal to, so this was R1 equal to, and now R0 equal to. Okay, so R0 equal to R1 minus. So R1 is now 1 and minus R0. So R0 equal to 0. Okay, so now perform these things, 1 minus 0. So you will get 1. And this 1 is now storing to R0. So that this value will be updated by new value 1. So, okay, so for every computation, read always the updated data, last updated data. Now, next instruction is R2 equal to R2 plus 1. So you can see right side. So read as a value of the R2, current value. So R2 equal to R2, what is the current value of R2? 2 and plus 1. And that result will be stored into R2 location. So 2 plus 1 will become 3. So that will be updated by 3. So after these 3 steps, that 4 to 6. Now this is the update in our memory space registers. Okay. Now we are checking that if R2 is less than 6. Okay. So now what is the last value of R2? 3. So 3 is less than 6. This is true because 3 is now less than 6. Correct. This condition is given as a correct. So go to step 4. Yeah, this condition is true. Go to step 4 and repeat the same thing again. So now when you are repeating this again, so you are getting R1 equal to R0 plus R1. So what is the now current value of R0 R1? So this is 1 plus 1. Okay, not 2. And you are updating this by 2. So that value will be updated by 2. And next is R0 equal to R1 minus. So what is the R1 now after updating the previous instruction 2? So read this updated value, okay, not the previous. So 2 minus that R0. So R0 is still 1. So 2 minus 1 is 1. So R0 will be updated by the same value 1. Okay. Now next is R2. So R2 is just a R2 plus 1. So R2 current value is 3. Now 3 plus 1, that will become 4. So 4. Okay. Now we are checking again. R2 is less than 6 K. So K is 6. So 4 is less than, again, so 4 is less than 6. Yes, this is again true. Okay, now repeat the same things again. Okay, so R1 equal to R0. R0 is now 1 plus R2. Okay, so sorry, R0 plus R1. So R0 plus R1 is now 2. So it will become 3. So this will be updated by 3. Okay, now R0 equal to R1 minus R0. So R1 is now 3 and minus 1. So it will become 2. So this is now 2 and R2 equal to 3, that 4 plus 1. So previous value of R2 plus 1. So this will become 5. 5. Okay, so now this is the updated value. Again, now R2 is 5. So 5 is less than 6. Yes, this is still true. Again, perform the same. R1 equal to R0 plus R1. Okay, so R1 equal to R0 is now 2 plus R1 is 3. So 5. This will update it by 5. And R0 equal to 5 minus that 2. This is 3. So this is now 3. And R2 is now 5 plus 1. So this is 6. So this will update it by 6. Now check. R2 is less than K. So now 6 is less than 6. This condition is not true because this is not less than, this is equal. So this condition is not true. That means this is false. At the case of false, go to otherwise. Go to step 8. Okay. So now perform this operation. So R1 value. So what is the current R1 value is 5. So 5 value will be upload that stored into this M2 location. Okay. So that means M2 should be 5 for this after performing the execution. So in this way, just do this type of calculation. So if you have already understand these, so that will be good for you for the exam. So you will get this type of questions in the exam. Okay, and if you understand this sequence of instruction, how you are performing this control statements or all these things, so that means you should also understand the program execution, that C program execution in the big 3 and big 4. So that is also the very similar, but we are using only C syntax there. Yeah, okay. So this is the first thing, and after that, big two. So big two, basically we will discuss this number representation in the computer. So we have this binary number system, octal, decimal, and hexadecimal. After that, conversion between number systems. So let me discuss this quickly. So decimal, okay. So we are use this decimal, and we use like as a base 10. If any number is given here, and we use as a base 10. So what is the meaning of this base 10? That means to represent any data, any value, we have 10 digit for this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 only. Okay, so 0 to 9. So we have this 10 digit, and we can represent any data with the help of this 10 digit. So because of that, this is called as a decimal number. In binary, we have only two digit. Okay, so this is called as a base 2, and we have only two digit, 0 and 1 for that, and we will represent all data with the help of this two digit, 0 and 1. Octal, we have 8 digit. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now we have only this 8 digit, 0 to 7, and we will always represent the data with the help of this 8 digit. And hexadecimal, we have total 16 digit. Okay, base is considered as 16, and we have total 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after 9 we will write a different character. Okay, so like we write like A, B, C, D, E, F. Okay, so these are the character, but the meaning is will remain same. So this is 10, this is 11, this is 12, this is 13, 14, and 15. Okay, so these 16 digit we have. After 9 we will use A, B, C, D, E, F, but the value will remain 10, 11, 12, 15 like this. Okay, so with the help of these digits we can represent any data. Okay, so decimal all. So how we generally use for binary. Okay, so binary is important. So in binary representation, so we have only 0 and 1. Okay, so that means base 2, we have base 2. And now the many time this question is asked like, suppose if you have bit. Okay, so suppose if you have one bit representation. Okay, so how many different value you can represent by the one bit only. So one bit means you can use only one bit to represent data, and you have two value for that, 0 and 1. So that means for uniquely, if you have one bit, you can represent two value, 0 and 1. Okay, and suppose if you want to represent any data with the help of 2 bit. Okay, so that means you can represent data with the combination of 2 bits. So for that, how many unique data you can represent with the help of two combination bit. Okay, so that you can write like 0, 0, 0, 1, 1, 0, 1, 1. So these are the possible combination with 2 bits data. So that means 4, here 2. Okay, so same for 3. So if you are given 3 bits, then how many bits you can represent? So that means you will always use 3 bits to represent all data. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the possible 8 combination. After that, you have to increase 1 bit. Okay, so these are the total 8 data you are representing. And what is the range for this? So actually in the number representation, so that 0 is considered as a 0, and this one is considered as a 1. Here same things, 0, this is 1, this is 2, this is 3. Okay, so if we are following the range in this way, so for any bit, so 3 bits, what is the range to represent the data? So that we can see that how many numbers we can represent, you can simply calculate 2 to the power 3. So this 3 is representing number of bits. That means you can represent 8 unique data. Okay, here 2 to the power 2, that means 4, 2 to the power 1, 2. Okay, so this calculation you can directly return. So this type of question asks, if you have 8 bit, how many unique characters you can represent. So you can directly calculate 2 to the power 8. Okay, so that is 256. That means 256 character you can represent. And reverse question is also asked. Okay, so reverse means, suppose if you are given like that you are given as a 17, or we can say 21, you have 21 different character. Okay, 21 different character. And how many minimum bits is required to represent this 21 bits, 21 different unique characters? Okay, so how many minimum bits is required? So that you can do like this. So you know that when you are using 2 to the power 3, you are getting maximum 8 character representation. 2 to the power 4 bits if you are using, that 16 you are representing maximum. Okay, so you cannot represent more than this with the help of 4 bits. But when you are using 5, so it will become 32. So always like this 21 is greater than this. Okay, so 21 but less than 32. So always pick the upper side, not lesser, because you cannot represent 21 characters with the help of this 4 bits, because this is greater than 6. You can represent only maximum 16. But yeah, here we can represent 32 different characters, and we have less characters than this. Okay, so just check the closure upper value which you are getting from this power 2 to the power. Okay, so that means that 21 data representation you need at least 5 bit. Okay, so this type of question is also asked in the exam. So if you have like 21 different characters, so how many bits is required? So just figure out that in the 2 to the power calculation, which one is the closest value you are getting, and how many bits is required for that. So that is called as a minimum bit requirement. Okay, and for number representation, so like this 2 to the power 8, because when we calculate this number, so this number is start from 0 when we are using any binary number system. So that is start with 0 0 0 like this. Okay, so that if you are taking 8 bit value, so that is start with 8 0. Okay, this, and that is represented by 0. So what will be the largest value for 8 bit? So if you are starting any value from 0, so you are getting 2 to the power 8, 256. This is the total number. Okay, so the total number you can represent, but you are starting from 0, so one value you are using for this 0. So that means last value will be 255, and that will be really represented by like this. So 4 4, yeah. So this is the representation for 255. Okay, so we have already seen 15 and 0 and 15. So 2 to the power 4 we can represent 16 number, and number is start from 0 to 15. Okay, and in hexadecimal you can see that this 15 is represented by F. Okay, so this is the important point or topics you can just remember for calculation for the binary related things. And after that, uh, conversion. Okay, so conversion is also important, and so first conversion is decimal to binary. Okay, so this is very common. So like we want to represent this 24 in decimal to binary. So how this 24 will be represented by in binary? So this is decimal. Yeah, please ask. Open your mic. Yeah.
Sir, I have one question.
Mm-hmm.
Sir, like you told that 21 characters can be represented by 5 bits.
Yes.
So means how the question will came.
Also, the question will be given like you have 21 different characters. Okay, and we how many minimum bits is required to represent this 21 uniquely? Okay, so that means different representation for each character. So 4 bit you cannot represent, because if you are using 4 bit like 0 0 0 0, so that means you have 4 bits for each number representation. So in that way you can represent only 16 number maximum. So that is 0 and that is 15. So 0 to 15. So and here you have more than this 16. Okay, so 21. So for 21 representation you have to increase one more bit. After that you can represent maximum 32 number. Okay, but this is coming less than, so that means this will also be handled by the 5 bit. Okay,
Okay, sir.
Hmm. Okay, so now this number conversion. So 24, suppose this decimal is given. So every decimal conversion we get, you can use this division method. So this is easy, okay, compared to the other method. So like you can just perform the division and just store the remainder. Okay, so you can, if you are converting this into a that binary number, so divide by this two. Okay, so that means division operation will perform by 2, and just perform the division operation and store the remainder at each step. Okay, so now when you are dividing 24 by 2, you are getting 12, and what remainder you are getting? 0. Then again divide by 2, so you are getting 6, remainder is again 0. Now again divide by 2, so 2 3 is 6, so that 3, this is again 0. Now again divide by 2, so 2 1 is 2, so that means 1 you are getting 1, but we are getting remainder 1 now. And when you are dividing this by 2, so that means this is only a remainder 0. Okay, so this step is not there. So last time when we are getting 1, we can stop here, so that means we can stop at this position, and after that we can read this reminder things. Okay, so or we can write like this 1, and we read this from bottom to up manner. So that means this will come here 1 and 0 0 0. So this is the things. Okay, so this is not a reminder, this is a that how much that what is the another term actually used. So we will only store the reminder things. Okay, so that, and we will read that reminder inside the bottom to top manner. So that is actually a binary representation for this 24. Okay, so this is the conversion. So this is the standard way, and you can convert any decimal number with the help of this. Okay, so suppose if you want to convert this 24 decimal number to octal number. Okay, so octal means 8. Okay, we have already seen we have only 8 characters, so the same things 24 and divide by 8 now. Okay, so 8 3 are 24, so 3, now remainder is 0. Now this is the only 3, so this will remain 3 3. Okay, so now read from bottom to top, so that means 3 0. This is the representation in octal. Okay, and the same things 24, how you can represent this decimal value to hexadecimal 16. So same things, perform the division by 16, 24 and 16. Okay, so 16 1 is 16, so 1, and what is the remainder? 8. Okay, and after that 16, so this will be the remainder, so 1. So that means this 24 will be represent in the hexadecimal form 1 6 8. Okay, so this is the hexadecimal representation for 24. So any decimal number you can represent in this way. So I hope this is clear, this conversion division method. And now another thing is conversion from that another base, so like binary to decimal, octal to decimal, hexadecimal to decimal. Okay, so this another conversion. So suppose any number is given in the binary form, so like 1 1 0 1 0 1. Okay, so like, and this is given as it binary, but now we are asking that what is the equivalent decimal. So for this type of calculation, use this 2 to the power things. Okay, so like 1 1 0 1 0 1, because we are convert, this number is given as a binary, so start from right 2 to the power 0. Okay, and 2 to the power 1 correspond value, just write like this: 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, in this order. Okay, from right to left. And this is the multiplication, and in between addition operation. So that means 1 we are multiplying with 2 to the power 0, so this is actually a 1. So 1, then plus, then we are multiplying 0 with this, so you will get 0 for this. Okay, then 2 to the power 2 4, 4 into 1 you will get 4, and 2 to the power 3 is 8, but it is multiplying with 0, so just write 0 for this. And here 2 to the power 4 is 16 into 1 plus 16, and 2 to the power 32 into 1 is 32, so plus 32. Okay, add this, so you will get 48 and 52 and 53. So this is a decimal number. If you want to convert this, suppose if any that octal number is given. So like 137. Okay, so you will always get the number of octal where the you will not get any 8 and 9 digit in the that octal number. Okay, so you will always get from 0 to 7. So for this type of representation, so like this 1, 3 and 7, so this is now 8 to the power 0, 8 to the power 1, 8 to the power 2. Okay, because this is 8. Now we want to convert into a decimal. So now perform the same thing. So 7, we can write like 7 into 8 to power 0 plus 3 into 8 to the power 1 plus 1 into 8 to the power 2. Okay, so this is now 7 plus this is 24 and plus this is 64. So add this, you will get the decimal equivalent. So this is now 88 and that is 95 in the decimal. Okay, so same things you can perform with like you are given as a 1a. Okay, so this is hexadecimal representation. Okay, now what is the equivalent decimal for this? So same things, a and 1. Now this is 16 to the power 0 and 16 to the power 1. Okay, and plus operation. So a means 10. Now we will use this a as a 10. Okay, because this is the representation. 10 into 16 to the power 0 is 1 plus 1 into 16, so 16. That means 26. This is the representation for 26 in decimal. So this is the way to conversion from any another base to decimal. Okay, so this is the conversion. Other than this is like if any hexadecimal is given and you want to convert it to a binary number. So like that 1a is given in hexadecimal. Okay, 16, and that conversion you want to ask as a binary. So we know that in hexadecimal we have 16 digit total. Okay, so that means we need 4 digit to represent every data in this hexadecimal. Okay, so we will just write a equivalent binary number for each digit of the hexadecimal number. So what is the equivalent 4-bit binary number for this, and what is the equivalent 4-bit binary number for this a? Okay, so so you can just practice, you can just remember this 16 digit. Okay, so in binary numbers, this is actually very useful for every purpose. So like 0 0 0 0, so this is the representation for 0. So 0 0 0 1, then I'm just writing in the order. Okay, so 0 0 0 1 0 and 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 and 0 1 1 1. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. After that 8 will become like this, and again same repetition will happen. So 1 0 0 1 1 0 1 0 1 0, sorry, 1 0 0 1 1 0 1 1 1 1 0 and 1 1 1 1. So this is 8, this is 9, this is 10, this is 11, 12, this is 13, this is 14, and this is 15. And this is hexadecimal A, this is B, this is C, this is D, this is E, this is F. So you can just remember this numbering from 0 to 15. So this is very useful for the computation most of the time. Okay, if you have good practice, you can directly recall this. Otherwise you have to calculate manually by the binary number conversion. So here one number we can directly write like this, 0 0 0 1 in 4 digit. Okay, and what is the correspond a is equivalent to 10. Now 10 is represented by 1 0 1 0. So now this is the binary representation. Same things, if binary representation is given and hexadecimal is asking, so just pick yeah, so this is the important. So here suppose the number is given like this, so 0 0 0 1 and 1 0 1 0, and suppose one more digit is given like this. Okay, so what is the equivalent hexadecimal for this? So here what you can do, you can from right side. Okay, so from right side pick 4 digit, then again pick 4 digit, then again pick 4 digit. But if 4 digit is not there, only some digit is there, just put 0 to complete the 4 digit. Okay, so this is 1 just put 0. So this will not affect the value of the current value, but you will get the 4-digit set, and after that you can write the corresponding value. So this is a, okay, 10, and this is 1, and this is 1. So that means the corresponding we have this number, so corresponding hexadecimal is 11A. So this is the hexadecimal. So hexadecimal to binary, binary to hexadecimal, just remember that hexadecimal represented by 4-bit. So just pick 4-bit representation. So same things, if any number is given binary, so like this 1 1 0 1 0 1 0 1 1. So, and this is binary, and we want to find out the octal correspond. Okay, so octal means 8, and to represent 8 data, we need at least 3-bit. Okay, so 2 to the power 3 is 8. So we will pick combination of 3-3-bit this time from right. 3 and 3. If any another digit is given, so just put 0 to complete 3 set. So now what is the equivalent value? So this 0 1 1 is represent 3. 1 0 1 is represented 5. Okay, so now 1 1 0 is represented. So you can see here 1 1 0 is represented by 6. So 6 5 3. So 6 5 3. So this is a octal representation. Same you can do reverse. If octal is given to binary, just write the 3-bit representation for 3. So that is 0 1 1. This one is 1 0 1, and the 3-bit representation was 6 is 1 1 0. That will become binary. Okay. So these conversion are actually important. You should know that basic octal we are not using too much, but yeah, binary, decimal, and hexadecimals. So these are the important. So you can just revise this conversion and just revise the concept of this data representation in these 3 forms. So some question maybe will ask from this. Okay. So any query in this, that number conversion representation?
No, sir.
Okay. So just revise these topics. Okay, so another is that we have discussed this number representation sign and this negative numbers. Yeah. So negative number representation, we in lecture we have discussed 2 types. So sign and magnitude. So that means any number we can represent with the help of this like. So you can see sign and magnitude. So for this is the first way to represent the data. So the most significant bit, if we are representing any data, so most significant bit will be represented the sign actually. Okay, so 0 for positive and 1 for negative. So the remaining bits represent the magnitude or value of the number. So here for 8-bit system, you can see plus 18 will be represented. So that first bit will be represented by 0, and remaining 7-bit will represent the data. So 18 representation is this 1 0 0 1 0, and 2 bits will remain 0. Okay, so this is the representation for 18, and this plus this is 0 is for plus. So this is for sign magnitude, and for 18 this will become minus 1 for negative, and remaining will same 0 0 1 0 0 1 0. Okay, so this is straightforward. We are only using 1 bit for sign. So plus 0 means plus, 1 means negative, and remaining bits for number. But for 2's complement, this is the another way to represent the negative number. So here positive will remain same. Okay, so positive will remain same. There is no change. We will use, so same things here also we are using the that 0 means plus, and remaining 8-bit will consider as a that value. And but for negative numbers, we will just perform the 2s complement of the this 18 number. Okay, what we have for the positive 18 number. So you can see what is the 2s complement basically. So 2s complement is a 1s complement plus 1. So for 1s complement means we invert all the bits. That is called as a 1s complement. After that we will add 1 into that. So here we have this number, so 0 0 0 1 and 0 0 1 0. So this is the original 18, but we want to represent minus 18. So first we will convert into a 1s complement. That means we will invert all the bits. So invert means 0 to 1 and 1 to 0. So 1 1 1 0 1 1 0 1. So this is now 1s complement. Okay. After that, we will add is plus 1 in this. So then it will become a 2s complement. So this is a very similar addition. So like as a decimal. So here 1 and 1 we are getting uh, that means 2. Okay, which is 1. If we are adding that in the decimal thing, so 1 plus 1 is equal to 2, but now 2 is greater than 1. Okay, so this 1 is the last digit in our number system in binary. So that means it will become, so we will write like 0 in the binary here. So 1 plus 1 will become like 10. So it will become a 0 and 1 will come as a carry. So this 1 will come as a carry, and 1 plus 0 will become 1, and remaining will same. So 1 1 0 1 1 1. Okay, so this number is representing a minus 18 in our 2s complement representation for the negative number. Okay, but if you calculate the corresponding decimal number, you will get different value. But this is just a convention. So we will consider that computer will consider this as a minus 18, but the exact decimal representation is different. So if you want to calculate the decimal equivalent for this, that you will get the different, but computer will understand is a minus 18 in this representation. So this is just a representation of 2s complement. Just first convert into a 1s and then add plus 1. So now it will become a negative number. So this is also important. Just sometimes what happen, this value is given like, and you need to find out the 2s complement negative representation, and maybe sometimes ask that sign and magnitude representation. So directly convert that. Okay, so this is also one thing. And in this week 2, and I think nothing is too much important. So character representation, this is also not too much.
So we'll get this PDF.
Yeah, this is already available in supplementary, in your supplementary content. So instruction encoding, yeah, these things actually it just get some idea that what is that code is actually, but not remember all these things. So we are not expecting anything to remember this opcode, all these things instruction. If any question is asked, so like in your assignment we have discussed, so we have already given the meaning of the each instruction. So you can ignore the instruction directly, you can just read the comment and you can solve this. Okay, so you can see the here you can see this type of question, hexadecimal equivalent of the binary representation. So pick 4 number and convert directly. So assignment questions are very closer to your exam. Okay, so exam questions. So just practice on this. That will be very helpful. So okay, yeah, this type of question we have asked based on this instruction encoding, but you can see we have already mentioned the comment also for each instruction. So no need to just remember these things. What is CMP? What is JE? This is not the purpose of this course. Okay, but how the assembly code looks like, how they can perform. Actually, this is the next level when you write the C program after compilation. So our code is actually converted into this type of form. Okay, so this is called as a assembly language. Okay, low level language. After this, our code is converted into a machine code that is actually in the form of 0101 like this. So that is not readable. This is still readable. You can understand if you have enough understanding of this codes, then you can understanding this code also. Okay, but machine code you cannot read. So this is just a mediator code of the compilation process. Okay, so now, yeah, this is the important things from week 2. After that, week 3. So in week 3, yeah, important things are operators, variables. Okay. So basically C programming structure, now you know that you have already write many programs and things. So keyword in C, first thing is this important keyword, the word actually which is used by the programming language. So that word you cannot use as a variable name or like this. So here some words are actually used by the programming language and that have some meaning. in the program. Like you write the for loop. Okay, so you write for. So that for is defined in the programming language that word. Okay, so in the language. So that is called as a keywords. Okay, so these are many keywords given here. So maybe many of you have not used yet, but later you will use. Okay, so all these words which is already defined by the language, that is called as a keyword. Now next is important thing is variable in C. Yeah, variable just a label for memory location. Okay, because each memory location, when you are just writing a program, you are storing some data in memory. Okay, so that memory is assigned for a program for you. So suppose you want to store some data 10 in some memory location. So some compiler will allocate some memory location, and that 10 data will be stored at that memory location, and each memory location have some address. Okay, so that memory location is identified by the address, and that address is represented by some hexadecimal number, and that is very you cannot remember that number, like this will be represented 1 a b 00586, like this type of some value. Okay, for this address. So each memory location is identified by some address, and that you cannot read or you cannot remember like this, and that is also not readable. Okay, so what you can do, you can just give, you can assign some label for this memory location, and that label is actually you can define. You can just give any name which you can easily understand what type of value you are storing in this memory location. So that suppose if you give the name like this is age. Okay, now this age is just a label, and this memory is now linked to this age, and now this data is stored in this memory location, but now you can access this data with the help of this label. And now you easily understand that this is age, and this 10 is representing some age in value. Okay, so you can define the name of this label, that is called as a variable. Okay, and that easily you can understand. So variable are named storage location in the computer memory that holds data. Okay, so they are used to store and manipulate data in program, and after that you can use this label to fetch the data and store the data or access the data, like, and manipulate the data. So but there are some rule for this label defining. Okay, so you can give a name for this, and but it have some rule. So that rule you should know. So variable declaration, so how we declare the variables, so this is the syntax which you should know. So what type of data you want to store, so this is the syntax basically. Okay, data type, you have to define data type first, and then you have to give name for that variable, then colon. Okay, so this colon is very important syntax for the C. You have to write this colon after every instruction, okay, in the code. That is information for the compiler that this is the line which is completed at this point, and compiler will execute this. So data type, you have to tell to the compiler that what type of data that variable is actually linked. Okay, so suppose if you want to store age, you are giving the name age, and this age will contain the value which is integer type. So you have to declare this variable like this: data type, then name, then colon. Okay, so this is the declaration. Now initialization, if you are assigning some value at the first time, okay, so that is called as the initialization. With the declaration you can also do this. So at the time of declaration, so you are declaring as well as initializing. Okay, so here this is now declaration, and same time this is now some value is assigned for that. That means some value is stored at this location, so that is called as the initialization. So that means initially you have assigned some value, so that is initialization. Now naming rule, yeah, this is the standard rule now. For you can use only letters, digit, and underscore. Okay, now many compiler is actually also using this dollar. This is but this is not defined anywhere in the document. Okay, but many compiler is also supporting this dollar for the naming. You will not get any error if you are using this dollar in the naming, but other special character will not be used. Okay, so only underscore, digits, and letter will be used for the naming of the variable, but there are some rule. They must start with letter or underscore. That means you cannot start any variable name with number. Okay, so like you cannot write like this one user. Okay, so this is invalid. You cannot start user that variable name with numeric number. Okay, digits. You can only start with letters and underscore, but you can use this digit after that. Okay, variable names are case sensitive. Yeah, so if you are writing that you can see example my var, so here v is capital and another is v is small. So now case sensitive means if you are writing any variable name in uppercase and lowercase same character, so that will be considered as a different way. Okay, so that is this here in C variable are case sensitive. C has reserved keyword, they cannot be used as a variable name. So if any keyword, suppose yeah, this is very important, okay, for the question purpose. So some variable names are given and ask that which one is the valid or which one is not valid. Okay, so suppose in between some while is given. So this while is actually, if you don't know that while is used for the loop, that is a keyword in the language. So this is looking like this is following the rule, but it is not valid because this is defined in the language while. So because of that, you can just go through this list once and you can just look at what are the keywords which is defined in the language. Okay, so now this is the rule which is important for the exam purpose. Just remember this. And after that, data types. Okay, so data types is used many times in the programming. If you're writing anywhere, if you're declaring any variable, if you're declaring any function, then you have to define this data type. Return type you have to define. If you are using any parameter, then you have to define this data type. And also reading and printing, you have to use this some specifier for the data type. So that is important. So what type of data you are actually using in your programs, you have to define that. So generally we have these common data types. Okay, so that int, okay, int integer, this typically takes 4 bytes in the most of the system. Okay, and one sort of data type for this we have, and char is also a data type, and we can also say that is also a one integer data type that takes only 1 byte. Okay, that takes only 1 byte. You can also store integer value for this char data type. Okay, but that will only store that 1 byte data inside the memory. Okay, and corresponding some ASCII character is also linked with some that integer value, so that is actually stored. So you can represent this characters a, so corresponding ASCII value will be stored at this location. So when you print this a with the help of specifier d, %d, so you will get the some integer number corresponding for this. Okay, that is actually a corresponding ASCII code. So after that, you have also one sort. Okay, so sort consider takes 2 byte. Okay, so that the range of storing the data is less compared to this int. This is takes 4 byte. This is sort is takes 2 byte. Char takes 1 byte. Okay, so you can store this characters with this help of char. Float, if you want to store some the decimal number with single precision. Okay, so that is also takes 4 byte, and you can store this type of floating value with this double. Yeah, this is another floating type of variable, so that is actually double, but this have double precision. So that takes size 8 bytes. So suppose if you have very long value in the floating part, so you can use this double. But for suppose for long this type of value, if you use this float, so you will get some data loss after some that floating value. So these are very common. So this is what not very common. So we generally use the integer. So true we can represent by 1, and false we can represent it by 0. Okay, and basically 0 is represented false. Other than 0, any value represented by true. So we can generally use instead of this bool. This is not defined in this standard library. We have to add actually some library for this. Okay, so we can use generally this 1 and 0 things. Okay, if you want to perform this, we directly not use this true and false. In Python we directly write. Okay, so because of that, the C actually it is written as a integer from 1 and 0. So void is represent like nothing. Okay, so this is another data that type represent the absence of a value. Okay, so that means we have no value. So that is called as a void, typically used by the function that do not return the value. If we are writing any function and we are doing some task, but after that we are not performing something or not returning anything from the function, so at that case we use this return type data type void. Okay, so that means this function will not return anything, so that is nothing. Okay, and we are simply printing, so that will be print on the output console, but this code will not return anything to the code. Custom data type, these things we will learn later. Okay, so we can also customize some data type. And yeah, this is some modifier of the data type. I have discussed short, long. If you want to store a big value, so we can use this long, like long int, long int. We can increase the range, like, okay. Signed and unsigned, this is also one type, so we can also write this unsigned int. So that means the value will be stored, that will be the only always the positive value, so 0 to positive side. But if we have any signed things, so we will use this signed int. Generally this normal int is also a signed int. So this const things we will discuss later. So yeah, after that, operators. Okay, so this operators is also, you know that in mathematical you have already used these operators. So we have arithmetic operators like this addition, subtraction, multiplication, division, and modulo. Okay, this is that percentile is represented as a modulo or remainder. Okay, so this is important here in our expression. You cannot write like this. Okay, so like this code is given, we cannot write like this. So like we have x and y value and we cannot write xy. Okay, so compiler will not understand this. In general, we in the normal expression in our mathematics, we generally write like this xy in the multiplication. Okay, so but if you are writing like this, compiler will not understand this and will give error. So for multiplication, you have to write like x into y. Okay, if you are also using brackets, still you cannot write like this. So x equal to a plus 2, you cannot write like, okay. So this will also wrong. So x into then a plus 2 you have to write. You have to also always use the operator. You cannot skip without operator, that like, okay, like this. So just remember these things. So otherwise the operators are same which you have already used. So now this, just remember this operator. So this is return the remainder. And apart from that, these are arithmetic operator. Then we have relational operators. So relational operator means when we are comparing two values. Okay, so that means we are comparing the left side and right side of the operators. So that is called as a relational operator. We are just finding out the relation between two value. Okay, so compare value always return Boolean output. Okay, so Boolean means either true or false, and the operator are commonly this one. Okay, so this is equal to, when we are checking this 2 is equal to 2, then this condition is true, it will return like a 1. Okay, true. And when we are writing a equal to, we want to check a value is equal to b, so we will write like this, a equal to b. So this condition will be checked. If this condition is true, so you will get 1, otherwise 0. Is not equal to, if you want to check not value are not equal, then you want to true, then use this sign. Less than, okay, so like if a is less than 10, so we use this. If this value is less than 10, then we will do something. So we will write this greater than, less than, equal to, greater than, equal to. Okay, so these are common relational operator. This always return the Boolean output 0 or 1. Now logical operator. Yeah, this is also important. I have discussed in the previous session. So this is very important. Some operations, suppose if you have condition 1, condition 2. Okay, now this is comes between different condition. Okay, and like you have two condition. Condition means one side you are writing like a equal to b, and another side you are writing that c is less than 10. So these are two conditions, and in between you can write like this end condition. Okay, so that means you are checking two condition, and you are also using logical end. So that means you will always that overall output for this two condition, that means you will get true if both condition are true. This is the meaning of this logical end. Logical end means both conditions should be true, then you will get the overall true, otherwise you will get zero. So in this case, in generally the programs ask related to this, so this is important. So compiler actually looks this. So you know, we have already mentioned that if both conditions are true, then output will be true, otherwise false. So if compiler is checking the first condition, okay, c1, and the first condition is false, then second condition will not execute, not check, ignored by the compiler. Okay, so if any operation is performing in second, like we are using some pre-increment or post-increment in this, okay, so that operation will also be not performed, that will be ignored if first condition is found false in the end sign. Okay, so if first condition is false, overall output will return as a false without checking the second condition. If first condition is true, then compiler will check the second condition, and if second condition is true, then overall will be true. If second condition is false, output will be false. Okay, so just remember this point. If first condition is false, second condition will be ignored completely. No operation will be performed in the second condition. The checking operation, any increment operation, assign operation will not be performed. Okay, it will be completely ignored. So this is for AND condition. And for OR logical operator, so if you have C1 and C2, two condition with OR, so OR sign means if any of the condition is true, output will be true. So in this case, if C1 is true, compiler check the first condition. If C1 is true, then compiler will not check second, because if any condition is true, output will be true overall. So if C1 is true, output equal to true without checking this. So this will be ignored completely. But if first is false, then second condition will be checked. Then if this is true, then output will be true. If this is false, then output will be false. Okay, so just remember this point in the case of OR operator. Okay, so if any pre-increment and post-increment or any assign operator in any operation is performing in second condition, and first condition is true, then the second condition will be ignored without doing anything. Okay, so this is the meaning of OR. Not is just a logical end if you want to check any condition which is not true. Okay, so if A equal to B, and we want to just use this sign, so that means if this condition is not true, then we are checking. Okay, so if this is returning true, it will be converted as a false, output will be false with the, by this. So this actually this operator will invert the Boolean result for this. Okay, so this is now logical operator. Now assignment operator. So all these are actually assignment operator. We generally use this. Okay, so equal, you know that A equal to 10. Okay, or sometimes we write A equal to B like this. So this is equal sign. That means this is the value. This is assigned to this one. Okay. And we also use shortcut, this add end sign. So we are writing like A plus equal to 10. That means A equal to A plus 10. Okay, we are adding into the same variable that value 10. So just you can change, use this in the same way. So A minus equal to 10 means A equal to A minus 10. Okay, so same way you can use all. All are the assignment operator. Now increment and decrement operators. Yeah, this is important. So here plus plus. So when we are writing this A plus plus, mean is A equal to A plus 1. This is the increment operator. We are incrementing the value by 1. Current. Okay, very well. A minus minus equal to A minus 1. Okay, we are decrementing the value by 1. So this is increment and decrement. Now this is the more important. Okay, so pre-increment and post-increment. Yeah, so you can just read this. We are writing like this. So this pre-increment and post increment, this is actually used with some variable, not value. We cannot write like this, okay, 10 plus plus or plus plus 10. This is the first thing. We cannot use this with any numerical value like this. Okay, we always use this with some variable name. And the operation is pre-increment means if anytime if you're finding like a equal to plus plus b, okay, and you are performing like 10, these things. Okay, so pre-increment means in pre-increment the value of the variable is incremented before its current value is used in the expression. So here this is the expression, okay, so this b plus 10 is the expression. But if we are using this pre-increment, so that means this current value of b will be incremented by 1 first, then it will be added to the 10. Okay, so that means before using in the expression, this value will be incremented. Okay, so that means if b equal to like 1, so the here what will be the total output? First we will increment this b value, so this will become 2, then plus 10. So total a will become 12. So this is the meaning of pre-increment. Before we will increment this current value before using in the expression. And post increment is we will use the variable value, current value of the variable in the expression. After that we will increment this value. Okay, so same things. If I am writing a equal to that b plus plus, okay, and now adding plus 10. Okay, so this is now post increment. So in this case we will if we are writing some expression like this, so a equal to b plus plus, b plus plus and plus 10. So what will be the meaning? We will add the current value of if b equal to 1. So that means a will operation will be performed like this, 1 plus 10. Okay, so this 11 will be assigned to a. After that this b will be incremented. So after using the current value of b in expression, then we will perform the b increment, that plus 1. So now b will become 2. Okay, so in post increment the value of the variable is used in an expression first and then it is incremented by 1. Okay, the current value is used and then the variable is increased. This is the change. This is the difference between pre-increment and post increment. So just practice on this. You can just explore this by experiment on the compiler, so you will get clear idea. Okay, now expression is simple. You are performing some calculation between variables. So expression that calculate the sum of x. So this is called as the combination of variables and operators. Okay, that is called as the expression. Now operator precedence, and this is also important. Operator precedence and associativity. So suppose if any expression is given like this, 2 plus 3 into 5, okay, and minus 1. Okay, so if a equal to this expression is given, so which operation will perform first and which operation will perform last? So that is called as a precedence of the operator. So here you can you know that we cannot solve this like 2 plus 3 first, 5 and then multiply 25 minus 1 like this. Okay, so this is wrong. So first this multiplication will happen. Okay, so 3 into 5 will become 15, then this value will be add here and minus 1. So both are now plus and minus, so that will perform normally. Okay, so 2 is 17 minus 1 16. This will be the answer. So this, if you have different operators in one expression, so which operator will perform first and which operator will perform last? So that is called as a precedence. So here this is given here that order of the precedence. Okay, so you can just remember this. So highest precedence is for, yeah, please ask if anyone have any.
Sir, precedence is just like word mass.
You can just yeah, that is the same things. But here we have lots of operator. Okay, so border mass is just a some limited operator, multiplication, division like this. But here in C programming we have many operators like this relational operator, we have logical operator, we have. So the precedence means is the same thing. So which operator will perform first? in the expression. Okay, so this parenthesis, if any expression have parenthesis, that will be the calculate compute first. Okay, so this is the highest precedence parenthesis. After that, this unary operator. This is also one operator that increment, decrement, sometimes is sign. Okay, so we want to convert that number into is like -1. Okay, so this is the number, and we want to represent as a negative. So we are just adding the minus before, so that operation will perform first. And this not, okay, this is also a, so these are unary operator that is actually performed with any single value, okay, or single variable. So that is the next higher precedence. After that, yeah, so this multiplication, division, that modulo, these have the next level. So yeah, what happened if you have this expression, so like 2 into 3 divided by like or we can say that 10 divided by 5. Okay, so in this case you have this multiplication and division. These now both operator are coming in the same precedence level. Okay, so multiplication, division. So in that case the operation is performed based on the associativity. So that associativity is defined as a, if two or more operator have the same precedence, then which side operation will perform first. Okay, so that operation will perform left to right side. Okay, so here multiplication will perform first, then division will perform, and it will not affect any answer. Okay, so it will not affect any answer, but compiler will perform this computation in this left to right manner. If you have like expression 2 2 plus 3 minus 1 plus 8 minus 6, like this. Okay, so here we are using plus minus, all have the same precedence. Okay, at this yeah, this addition and subtraction. So in this case compiler will execute left to right. So this 2 plus 3, then -1, then +8, then -6, like this. Okay, so this is called as a associativity. So this is for same type of precedence operator, the associativity is left to right. So now the you can just, this is the next level precedence, this is next equality operator next. So you can just remember this sum for the precedence. Associativity, most of the common that precedence operator, this is left to right, but this right to left is also there. Okay, so this you can see left to right associativity. If we have this arithmetic operator and the same precedence, so like in this example you can see 5 plus 3 minus 2, so this is left to right associativity. So this operation will perform first, then minus. And logical operator also, so if you have more than two logical operators, so this will check first and then it will check. Okay, left to right. But we have also right to left associativity. Okay, so that is for equal operator. So sometimes the expression is written like this: x equal to y equal to z equal to 5. So here operation will perform right to left. Okay, so this equal operator is that have the right to left associativity. So operation will perform this side. 5 will be assigned to z, then z become 5. Now z value will be assigned to y, then y become 5. Now y value will be assigned to x. Operation will be performed right to left manner. So this is called as a right to left associativity. Okay, so just remember this for equal sign. After that, this is input output that we have idea. Okay, so scanf, printf, these things. So now this is big 3. So just remember this important point: this pre-increment, post-increment is important, and or this or operator. So which I have mentioned that second condition will not be checked if and operator first is false, and in or operator first is true, then second condition will not be checked. Just remember these small points. Okay, so many program maybe you will find where this type of situation will be there. Okay, yeah, so this is from big 3. Now move to big 4. So big 4 is basically control statement where you should know the syntax of the loops and working of the loops. Okay, so how the loops is defined, how the loops is works actually, so that you should know properly. And conditional statements. So here in the first topic we have this conditional statement. So fourth week you will get definitely coding based questions. So that program script will be given and you have to run the code manually and then you will get the output something. Okay, so that type of code will be given. In between, this break and continue is also coming in the loop that I'll discuss. Okay, so if these are the conditional statement, conditional statements means we will define the control of the that execution based on some condition. Okay, and we will check some condition, and based on the condition output we will define our control for the execution. So that is conditional statement. You can see now we are checking this if condition, and here if this condition is true then we are moving to another side, and if this is false we are moving to another side. Okay, so that means we have two possibility, like in the example you can easily understand here. Here we are just using this one conditional statement. If x is greater than 5, then this block of code will execute. If this condition is not true, then this part will be ignored. Okay, this will be not executed by the compiler. So if x equal to 10, yeah, this is true. Now this will be print. If we are passing x, if we are assigning x equal to 1, then this condition is not true. Then this will be not execute. So now we are deciding our control of execution based on the condition. So we have this syntax if, and we can also use if else. Okay, so if we have condition true, we have some block of statement. If condition is false, then if we have another block of statement, then we use this else statements. Okay, so like this structure. If we have true, we have this body of if that contains some code. If our condition is false, then we have another body that contains some another instruction. So at a time, any one of the part will execute, either this one or this one. Okay, based on the condition. So this is if and else. So we can define our code in this manner. So if and else base, and we can also increase this chain more with the help of if else if else. Okay, so here if and else, in between we can use any number of this else if. So but we have to define condition for each if or else if. Okay, we cannot leave this else if part alone. Okay, we have to define some condition for this else if. So that means yeah, please ask. Yeah. Anyone?
So is it necessary that we have to use else if we don't have any condition other than if?
So you can skip this. Okay, so you can write if or else if only. This else is not necessary.
No. Only
Yeah.
if, like if I am just
You can
like
also
in the
use if. So
previous
the
program, yes.
yeah, first code is given like this. If we have only if condition and we want to do something, otherwise nothing. So we can
like
write
if
only
the
if.
if input is x is equals to 2, then what will be the output?
Nothing.
Means
If x
it
equal
will
to
not
2,
run with errors, right?
it will not run with any error. So it will check the condition and compiler will directly jump to this statement.
Okay.
And this is written 0, and the code will terminate. So no output will come here. Okay, so you can write this without else, you can write, but you cannot skip this if. You cannot write only, you can not write only else statement. Okay, so else need if statement, but if can only written alone without else. Okay, so same things in this else if condition. You to use this else if, you need at least one time this if, not one time or only one time, not at least. You need one time this if. After that you can write any number of times this else if and then else, or you can also skip this else, only write with else if like this. Okay, but you have to define condition every time if you are using else if. So this is the chain of the conditional statement. You can write like this. So if this is the condition, then this condition, then else condition. If and last, if you know that any condition is remaining, okay, and you want to perform something for that remaining condition, and you don't want to define that condition because that is the only one possible remaining condition, at that time you can write only else. Okay, but remember that at a time only one block of statement will execute in this chain. Okay, if else if else if else if else if else, in this block of statement at a time, only one block of statement will execute, not more than one. If the first condition is true, now this part will execute, this part will execute. The second condition will not be checked. Okay, if the compiler is execute, if this condition is true, it is now execute. So compiler will not check any another condition, remaining condition. All will be ignored. Yep, someone is raising the hand.
Sir, sir,
Yes.
how many branches will go, sir? Any limitations?
No limitation. You can do any else if number. So
Okay.
according to the document, I have never checked this how many else if we can put, but I think there is no limitation.
Okay, sir. Thank you very much, sir.
Yeah. So okay, so but remember this: if first condition is true, so the some that question is asked like this. So if x is greater than less than like 15, and we are checking something, and in next condition else if, and we are like performing x plus plus, okay, so and is less than equal to 10 like this condition. Okay, so what happening, this one pre-increment and post-increment operation is happening here. Okay, but if we are performing this type of else chaining, so this condition is true and now compiler is executed, entered inside this block, so this part will not execute. Okay, so sometimes this type of tricky question asked actually. So what happen if this is true, and so maybe sometimes you will check this also and you will perform this pre-increment. So but this is not true, this pre-increment will not perform if this condition is not true. If this condition is, this is false, and now compiler is checking this condition, now this operation will perform. Okay, if now this is true, then remaining will be ignored. So in this way this execution happen. And another type of conditional statement we have in C, this switch statement. Yeah, switch statement is also another version of if else condition. So here we have this type of control. Okay, so we pass some expression, this expressions gives some value, okay, as a result, and this result we used as a case number in our syntax. Okay, case, this is the keyword, and this value 1 is just a output of this expression, possible output, we can say that. We define this case value, and now we check if our value is matched with this case 1, then we will enter inside this. Okay, this case 1 is matched true, then we will perform some statements, and now we will perform break for the execution. Then after getting the break statement, we will directly exit to the switch statement. If suppose if this break statement is not there in our code, then what happen, compiler will check the first case matching. Suppose this case is matched, now this statement will execute, after that all statement will execute if any break statement is not used. Okay, so this is the switch case working. Sorry. Okay, so syntax is this: switch, we write the keyword, then we pass some expression, or you can pass any variable like a. What value you are getting for a or expression result, that will you will write as a case value. Okay, so you are getting, you if you initially know that what are the input possible for this a, so you can define that as a case 1, case 2, case 3 like this. Okay, and last value we write as a default. So default means if any case value is not matched with this expression output, so that default part will execute. Okay, so for every case after this colon we write some code statement. You can write any code blocks and you can perform that task. After that statement you need this break statement, otherwise all code will, all inner code will execute for the each case. Okay, but if you are using break, then your code, that statement will execute. After that this break will terminate this switch totally, you will get out after this switch statement. Okay, so just remember this control structure, that switch statement for the this, yeah, this is the example. You can see you are using day 2. Okay, you are getting some value, and we have defined this case 1, case 2, case 3 default. So if we are passing 2, that means compiler will check case 1. So this day value is matched with this one, no, then yeah, this is matched with this 2. Okay, so then this statement will execute, and after that you are getting break, so you will come out this directly to switch. If this break is not used, then this will also print. Okay, if this is not used, this will also print. Same. Okay, so this is similar to your if, else if like this. Okay, so here we are defining in different way. So yeah, this is the conditional statement. You can also use this nested condition like this. Inside one if, you can use another if. Okay, that is called as a nested if. So if this is, so this is similar to your another block of code that can also contain all the things. Okay, so like loop, conditional statement again. So this is just a block of code separately. Okay, so this is now nested if else. So same things. Now loop. A loop is the next control statement. And first thing we discuss for loop. So for loop working is like this. So we and we first perform initialization operation for loop. Okay, so this happen only one time. This instruction will perform one time. Next step is condition check. Okay, we check the condition. If our condition is true, then we will move enter into the loop body. Okay, this is the loop body and statements we are performing. After performing loop body, then we update our conditional variable which is defined inside the loop structure. Okay, then we update our conditional variable and then come back to the condition. Okay, so this is the cycle is performing like this one. Okay, if anytime this condition is false, then we terminate the loop and come out the loop. So we will understand by this is the syntax. Okay, and this is the initialization part where we have three parts in the loop brackets. When we write this loop bracket, we use this colon in between, we use this three part. So first part is actually a initialization part, this first block, this one. Okay, so when we are writing like I equal to 0, so that is performed only one time. After that, this is the initialization. After that, our control is actually check the condition, this condition. If this condition is true, then we enter into the body for loop. And after execution of this body, we come to this updation part, this part. Okay, and after updation the variable, then we come back to the condition. If this condition again true, then we will enter inside the loop, then again come back to this updation. Okay, so this is the cycle iteration is performed by the loop. So if you can see this code, now this line will execute only one time by the code, I equal to 1. After that, you will move to this condition. Okay, so I is less than equal to 5. Yeah, this is the condition, this is true. Now you will enter inside this will be print. Okay, so the question is asked related to this: how many times this loop is running, how many times this print statement will print something, how many times this condition will be checked. Okay, so this type of question is asked in the exam. So like this code is running, this is starting from 1, I equal to 1, and this is running less than equal to 5. So how many times this print statement will execute, and how many times this condition will be checked. Okay, so let calculate for this code. Okay, so first time we are checking this when I is equal to 1. So 1 is less than 5. Okay, less than equal to 5, this is true. Now this print will perform, so I am writing P. Now after this increment will happen. Okay, now I will become 2. So 2 is less than equal to 5. Yeah, this after increment we will check again. Yeah, this condition again, 2 is less than 5. Yeah, true, again print happen. Then we will enter again, and then again increment. So 3 is less than equal to 5. Yes, then print happen. Then again increment. 4 is less than equal to 5. Yes, print. Then 5 is less than equal to 5. Yes, equal to. Okay, so equal is there, so because of that this is true again, print. Now it will become 6 is less than equal to 5, false. Okay, so now this is the print statement. Okay, and now this is a false condition, and here we will end exit this loop. So how many times this print statement is performing? 5 times. But how many times this condition is checked? 6 times. Okay, 1 for false, 5 times it is 2. And also what is the last I value? So last I value is still 6. So you should clearly understand this updation, how this updation is happening in the loop. So I is now updated from 1 to 6. Last update I value is 6. That means condition is also checked 6 times. Initialization part is only run one time. This increment and update is also happen how many times? So it is also happening 6 times. Okay, not 6 times, it is 5 times. Okay, so one for this, 2, 3, 4, 5, yeah, 5 times. This increment and update operation is performed 5 times. So this is the weight of the run loop actually in the C, how the loop is actually runs. And sometime, so this is another code, sometime nested loop is also, you should know that how nested loop is run actually. So this is another loop, while loop. Let me just discuss this first. So in while loop, if you don't know initially how many times your code will iterate actually, and or you don't know the terminate condition when it will come, so we generally use this while loop. So in this while loop, initialization part we actually done before this while loop. Okay, so in any code we perform some initialization here. Okay, and after that we check the condition which we defined inside the while loop. If this condition is true, then we enter inside the body of while, and inside the body of while we update the condition variable. Okay, this is also very similar to your for loop, but here we update the variable inside the body, not the loop structure. So after checking the condition, if this is true, we will enter inside the body, then we will update, we will perform some statement, and after that we will also update our conditional variable, and then we will again check the condition. Okay, so we will repeat this cycle. At any point, if our condition is failed, now we will come out to the loop. So this is the example for this. This is the that syntax while, and this is example. Okay, so here you can see the same purpose example. Okay, so as the for loop. Now we have performed this initialization before this. This is the only one time. After that, we are checking this condition: I is less than equal to 5. Yes, and now we are performing print statement. You can see now we are updating our I value inside the body. So this is a same way it will work. So now when I equal to 1, the condition is true, the condition is checked true, and it will print. Okay, now we will update. So this is now I equal to actually 1. Okay, so I'm writing the condition. So 1 is less than equal to 5, then print. Okay, now 2 is less than equal to 5, then print. 3 is less than equal to 5. So this is incrementing every time here. Print. Okay, 4 is less than equal to 5, print. Then 5 is less than equal to 5, again print that, and we will increment again. Okay, so 6 is less than equal to 5, no, false, and stopped. This loop will terminate. So same things, how many times we are checking the condition? 6 times here. Print statement is performing 5 times, not for this. Okay, so this, okay, 5 times. Okay, so in this way we are performing this while loop. So this is some example. Yeah, this is the infinite loop condition. So if we are performing like this while condition 1, or if we are, suppose if we missed this one. Okay, so in the previous example, if we missed this line, then this code actually I will not update. Every time this will be 2, it will run as infinite. And this, if we are writing only 1, so 1 is considered as a true. If we are passing 5 also, that will also consider as a true. If we are passing 0, that loop will terminate. Okay, it will be considered as a false. So this is also important. 0 always considered as a, if you are passing value at the place of conditional statement. So 0 will be considered as a false. Any value other than 0 will be considered as a true. So sometimes we use this direct value. If we want to run this loop infinite times, so that we use this directly 1. And we can break this by the break statement. Okay, so do while is also another version of while loop. So that actually perform at least one time this do. So this is actually a do, and this is a while. So this statement body we will enter this into this, perform at least one time. After that we will check the condition. If condition again true, then we will enter into the same statement again. Okay, so that means what is the difference between while and do while? So while, that means statement part will execute after checking the condition. So that means if our first time if our condition is false, then body will not execute. But here doesn't matter what is the condition, this body will execute at least one time. After that we will check the conditions. Okay, so this is the difference. We are running the statement first and then checking the condition. So this is the syntax of do while. So do, then write this code, and after that while condition. Okay, so yeah, so sum of number, example, infinite loop, same things, infinite, terminate condition. So yeah, nested loop is also important. Okay, so this example, yeah, this is also important for the code purpose. So how many times this code will run, or how many times this star will print. Okay, so you should know how many times this star will print in the code when you have nested loop. So nested loop means you are running a
Sir,
loop. Hmm.
sir, can we continue tomorrow?
Sorry, can?
Can we continue tomorrow?
Uh, Tomorrow we have another session that mock discussion will happen. So this is the only last topic. So let me just complete this in 5 to 10 minutes. Okay.
Okay.
Yeah. So this nested loop is important because here what happening, we are running one loop, inside one loop we are running another loop. This is called as a nested loop. Suppose this question is asked that how many times this print star will perform. Suppose we are not using this. Okay, so how many times this star will print. So here we can write like this. So I equal to 1. So I equal to 1. This is the first loop. Row equal to 4 and column equal to 6. Okay, so we can take this value. So for I equal to 1, for this one value, how many times this inner loop is running? So because for this, when we are entering inside this body, this loop will run completely. Okay, so that means J will run. So for I equal to 1, J will run 1 to 6, total 6 times. Okay, that means 6 times this star will print. Now after completion of this J loop, then I will increment. I will be reach to 2. Then again J will run 1 to 6, total 6 times. Then I equal to 3, then J will run 1 to 6, total 6 times. And that I equal to 4, then J will run 6 times. Okay, so you can see I is starting from 1 and reaching to 4 equal sign. So 1 2 3 4. So this is 1, and for each value of I, this loop is running 1 to 6 equal sign. Okay, so 1 to 6, so total 6 times. So total 6 6 6 6 24 times this print statement will perform. Okay, so you should know this type of nested things. Okay, you can just find out that how many times this will print. And this is also proper break. Yeah, so this break, continue and go to statement. How this actually works? So break means we can stop the iteration at any point. Suppose this loop is running. Okay, so this for loop is running, and this is starting from I equal to 1 and it is less than equal to 10, but we want to break this loop iteration at any particular point. If any condition is satisfied, then we want to stop the iteration. So we use this break statement. Okay, so here we are running this loop. So I will actually 1, I equal to 1, this condition is not satisfied. Okay, so this will ignored, and this print statement will perform. So 1 will print. Then I equal to 2, so this 2 will print. Okay, so again condition is not satisfied. Then 3 will print, 4 will print. When I become 5, so now this condition is true, and this statement will execute. Okay, when I equal to 5. So at this time, this loop process will stop. Okay, now break means the closest loop. Okay, so suppose we have nested loops like that. For we have something, and this for is running another for. So the what closest loop is coming for this break, that will actually stop. Okay, and our control will come out to this loop. So after getting this break statement I equal to 5, our control will come out to this loop and we will move to the next instruction. So that means our code will only print this 1 2 3 4. After that, nothing. That loop will terminate. Okay, continue statement. continue statement, we have this. If we want to perform some operation, if here you can see we are running 1 to 10, but for even number we don't want to print, we just want to print only odd number for this. Okay, so what we can do, that continue at any time we are getting continue. So continue means we will directly jump to the next iteration without performing the remaining part of the code. We will directly jump to the next iteration from that point. So I equal to 1, this condition is not true, and we will print 1. Okay, when I equal to 2, so 2 is now, this condition is true. So we will directly jump to the next iteration without performing this remaining part, print statement. Okay, so that 2 will not print, then I will become 3, so 3 will print. Okay, so this continue means we will directly jump from that point to the next iteration without executing the remaining code which is coming after that of the loop. Okay, so that is actually the purpose of continue. Go to is also a one control statement that we actually use to jump to at any level, but we have to define the level point of the code. Okay, so here this is the example go to. So what we can do, we can decide the our label here. So suppose we have defined this start point. So start, you can write like this, start colon. This is one label. After, suppose if you are writing some operation, at any time you want to perform jump back. Okay, so you can write, use this go to, and go to and just mention the label which you have defined, start. So here from you will jump back to this point and this part will execute again. So this is also like a iteration, or you can also jump to the next side. Okay, not back, you can also jump forward. So this is, you have to define label of the code. You can jump back to any at any point with the help of this go to. Okay, so these are some control statement. Other things, single line statement, you can just practice. Okay, any query in this multi-line statement, comment, you should, that is easy. Okay, so just read this. Any query in this? Otherwise, we have tomorrow session where we will discuss the mock, actually. Okay, mock paper, and you can also ask your query tomorrow session.
Sir, when we will discuss week 4 graded assignments problem.
Graded theory assignment.
Programming and theory both. Actually, programming.
Programming. Okay, generally we not discuss the programming assignment before the deadline. If deadline is over, you can ask your query if you have any doubt in any query, that any question. Otherwise, that detailed solution is already there.
Week
Okay.
is already over, sir.
Hmm?
Fourth week is already over.
Fourth week is already over. So for theory assignment, you can see the answer explanation already available on the portal. Okay, so after C, you can just read this statement. If you are not getting any question clearly, you can ask tomorrow in session. Okay, so tomorrow is just basically to discuss the mock paper. After completion of the mock questions, you can ask your doubt
We
in the week
discussed
4.
already about the week weightages,
Week weightage is approx equal.
approx equal.
Approx equal for from each week.
Is it like third and fourth week will be more compared to
No.
second and
Approx equal weightage. Okay. So we are not
okay.
neglecting any particular week. Okay. So you can expect approx equal weightage. Maybe one or two number up and down, but approx equal.
Okay, sir.
Okay. But yeah, for programming assignment, I think we have no time to discuss this programming assignment. But graded we generally discuss when if you have any doubt. Okay. So tomorrow is the main target is mock paper and your doubt. Okay, so you can ask your doubt if you have any. Yes, Diksha.
Sir, I have a doubt from mock. Can I ask today?
Why not tomorrow? Because today is the deadline of the mock. So
Sir,
after.
I can't understand that question.
Okay, tell me which question.
Question number 6.
Okay, question number 6. This one?
Yes, sir.
So okay. What you are not understanding? What is this? Let me just yeah. What is your doubt? Oh, 1 second. Hmm. Yes.
So
What
it's
is your doubt?
written x equal to minus a increment. So this minus is for what?
This is simple minus value.
Like a increment is 2, so we will write minus 2.
This is increment, no?
Yes, sir.
So what is here actually? A equal to 1, b equal to 1, x, and a plus equal to b is equal to a plus b in the second line. So that means a is now become a plus b 1 2, and next line is x equal to minus a and plus plus b. Okay, so this is first thing. This is a post increment and this is pre increment. So for expression, this post increment will perform after the using the expression. So minus a means we will
Minus 1.
so minus 2, not 1.
Yes, sir.
Yeah, okay, the last updated value is 2, so minus 2 and plus. So this is pre increment. Pre increment will perform before this, so that means b value is still 1. So 1 plus 1 2. Okay, so
Yes.
now x become 0.
0.
Okay, and now we are printing x, so this should be print 0.
Yes, sir.
So this is just a minus, is not changing. This is just a operator. This is unary operator that is actually changing the value of a in the expression.
Yes, sir.
Okay, but now in the expression we are changing the value, but a's value is not changing.
Yes, sir. Thank you, sir.
So you can also discuss tomorrow all these questions. Okay. Okay, any other query or any doubt?
Thank you, sir.
No, sir.
Okay. Okay, then
Thank
fine.
you, sir.
We'll see you tomorrow. Thanks everyone. Bye. Good night.
Good
हेलो
night,
सर
sir.
Good night, sir.
Good night.
हेलो सर
Yes, Aniket.
सर थोड़ा ये मेरा मतलब सिंपल सा डाउट था कि जैसे जो हमारा अगर 7 जुलाई का जो अभी एग्जाम है अगर इसमें बेटर नहीं होता है परफॉर्मेंस तो जो अगस्त में जो 4 अगस्त को एग्जाम देंगे तो सर इसके लिए क्या क्लासेस चलेंगी क्या प्रॉपर?
नहीं, अगर क्वालिफायर नहीं होता है, ओके, तो क्वालिफायर ना होने के केस में दोबारा चांस मिलता है रीअटेम्प्ट का, दोबारा देने का, लेकिन उसके लिए क्लास दोबारा नहीं चलेंगी, आपको खुद से ही पढ़ना पड़ेगा, क्योंकि क्लास तो कंटिन्यू हो जाएंगी ऑफ वीक 5 से वीक 6 7 लाइक दिस। ओके, सो हम तो मूव कर जाएंगे आगे को, पर आपको
सर
अपना वीक 4 का कंटेंट रिवाइज करना पड़ेगा खुद से ही।
तो सर जो हमारा बैच रहेगा सर ये मतलब मई वाला ही बैच रहेगा ना?
हाँ, बैच वही रहेगा, पर
ठीक है सर।
उसमें से कुछ क्वालिफाइड हो गए होंगे, कुछ नहीं हुए होंगे, तो जो नहीं हुए होंगे वो उनको सेल्फ स्टडी करके नेक्स्ट टाइम एग्जाम दोबारा देना है।
ओके
ये
सर,
होता है
ओके
ऐसे।
सर। थैंक यू सर।
ओके,
और सर सितंबर का अगर जो बैच है उसमें सर आप पढ़ाओगे?
नहीं, दोबारा से जो एनरोलमेंट होंगे सितंबर के टाइम पे फिर से ये कोर्स चलेगा, तो फिर मैं ही पढ़ाऊंगा, हमारी टीम ही पढ़ाएगी जो है।
अच्छा ठीक है सर, थैंक यू सर।
या ओके, बाय एवरीवन, गुड नाइट।
Good night, sir.
गुड नाइट सर।
गुड नाइट।